Hello, ladies and gentlemen. Thanks for tuning into part 2. In this section of the 4B videocast, we're going to work on calculating net force or finding net forces. So to begin, you need to complete your net force Avid bookmark. You may need to stop the video in order to be able to include all of this information on your bookmark. So feel free to pause and then resume as needed. So the definition of a net force is that the net force is the vector sum of all the forces that act upon an object. There are two very important states of forces. When forces are balanced, then that means that the forces that oppose one another are equal in magnitude or equal in strength. In this case, the example shows that the normal force and the force due to gravity are balanced. So these forces are the same magnitude, so that means this is balanced up and down. When forces are balanced, the object is either not moving or moving at a constant velocity. It's absolutely critical that you get that straight. Balanced forces mean two things. The object is either not moving or it is moving. When it's moving, it must be moving at a constant velocity. So two states that can be happening when forces are balanced. When forces are unbalanced, it's actually easier. So in this next bullet, when forces are unbalanced, then that means that the object will accelerate in the direction of that net force. So if we look side to side here and compare the applied force to the friction force, the applied force is larger. So when we add these two together, we'll end up with a net force in the direction of the applied force. That means that this force diagram shows an object that is accelerating in the direction of the applied force, since the net force will be in the direction of the applied force. Always remember that when you add forces to find net forces, you must only add forces that are collinear. So we don't want to ever add the normal force to the friction force because those two are perpendicular to one another. We can add the normal force and the force due to gravity or the friction force and the applied force. Very important that the forces that are added to create net force are collinear. So let's look at a few examples so you get kind of a feel for how to come up with net force. It's easier than some of the other things that we've done, so that's a good thing. In this example, we're going to use the convention we've used so far, where that we say that forces that move to that indicate they're acting to the right are positive, and forces that are acting to the left are negative. So in this first one, we have 5 to the right plus 5 to the right. Both values are positive, so positive 5 plus positive 5 gives us a net force of positive 10. That's logical. If we have two forces pushing to the right that are each 5, then the resulting force to the right would be 10. This next one shows a situation where we have 5 newtons to the right and 5 newtons to the left. So these two acting in opposite directions and having different algebraic signs but the same magnitude, when we add 5 plus negative 5, we get 0. So this is an example of balanced forces. The next one, 5 newtons to the right, that's positive, plus 10 newtons to the right, which is also positive, gives us a really large 15 newton force also to the right. The next one, 5 newtons right plus 10 newtons left is 5 plus negative 10, giving us a net force of negative 5 newtons, or 5 newtons back to the left. The next one, 5 newtons right plus negative 15 newtons left, is going to give us a negative 10 newtons left. And then in our up and down example at the very bottom, 10 newtons up plus 5 newtons down will give us an answer of 5 newtons up, and we've established up as being positive. So let's go ahead and look through this video cast that my colleague has made that gives you just a little bit more practice on these. He starts with some of the examples we just worked through, and then also at the end gives you some examples using force diagrams.
Alrighty, welcome back. In this video, I'm going to teach you how to add and subtract forces so we can find the net force. So in this first example, I've got one force which is pointing to the right with a value or magnitude of 5 newtons. Also, I have a force that is pointing to the left with a value or magnitude of 5 newtons. What I want to find is the answer. We call that the net force. What is the answer when we add these forces, the net force? So if an object is pointing to the right, it will have a positive value. It will have a value, in this case, of 5 newtons, positive 5 newtons. However, if an object is pointing to the left in the negative direction, we will just call that a negative number, so in this case, it will be negative 5. So 5 plus negative 5 will give us an answer of 0 as our net force, and that is the magnitude. But we also need to always show direction, but in this case, since it is 0, there is no resulting direction. Let me go ahead and show you another example of finding net force. In this particular example, we're finding the net force of two forces in the vertical or up and down axis. This first one on the left has a value of 10 newtons pointing to the left, which is a positive direction. Going up is positive. And then the next force is 5 newtons pointing down. However, that will be in the negative direction. So when we add these two forces up, it will be 10 newtons, positive 10 newtons, plus negative 5 newtons, because it is pointing downwards. Our answer, which is our net force, 10 plus negative 5, we get an answer of 5 newtons. That is our magnitude, but then we also need to show direction. Which way is it? It is 5 newtons, positive 5, so that is 5 newtons upwards. That is how you add, subtract forces to find the net force. Next example is a force diagram like we created in an earlier video. We have air resistance pointing up, gravity force pointing down. We want to find what the answer is for that particular force. So if we have positive 600 because it's going up, adding negative 800 because it's going down, let's go ahead and write it out. So 600 newtons plus negative 800 newtons. That is equal to negative 200 newtons. Or otherwise, we could write it as 200 newtons downwards. So we can show the magnitude as well as the direction. Our final example, we've got 3 forces, so this is kind of a special force diagram. Let's go ahead and analyze the forces that are opposite from each other. So the force going up is positive 50 newtons. The force going down is negative 50 newtons. So positive 50 plus negative 50, our net force is equal to 0. So they are balanced, so they cancel out. In the other direction, the horizontal, we've got a force pointing to the left, which is negative 20. And then we also have no force on the right, so that's 0 newtons. So negative 20 newtons plus 0. Our net force for that is negative 20, otherwise known as 20 newtons in the negative direction, which is to the left. Thank you for watching. I hope you enjoyed it.
All right, ladies and gentlemen, so in summary, force diagrams are vector drawings that show all the forces that act on an object. And we learned more about that in part 1 of the video for 4B. Then net force is what we learned more about in this video. So in part 2, we learned about net forces as the vector sum of all the forces that act on an object. When we find net forces, we have to be sure that we are adding up forces that are collinear. So we can add up and down forces together. we can add side-to-side forces together. And if you find that the net force in a certain direction is 0, then you know that the forces are balanced and the object is either not moving or it's moving at a constant velocity. If when you add up the net forces, you get a net force that's not 0, then you know that the object is accelerating in the direction of the net force. All these things require practice, so the next step is for you to invest a little bit of time in some practice. Thanks, ladies and gentlemen.